Okay, thank you. Okay, all have joined. So, any of you could have been able to create any presentation on that topic, function or computational problems?
Yes, sir, we tried.
Yes, sir.
No, you tried meaning you have something, some PPT?
Yes, sir. Yes, sir.
Yes, sir.
PPT, yes, sir.
How many groups? One group?
It's a group of 4.
Okay. So please register your names with Manohar.
It's Siddharth, Anvesh, Anshul, and Manav.
Manohar, please.
Can you repeat that?
Siddharth, Anvesh, Manav, and
You do
Anshul.
one thing, Siddharth,
Roll.
you type the names or only the roll numbers also you can type of all the 4 in the chat box. Parallelly, someone can start the presentation.
We need permission to share the screen.
Allow him, Manohar.
Yes. Siddharth, you can now present.
Yes, sir. Okay. So we are presenting about the functions.
Please start.
So a relation is said to be function if there is exactly one output for a given input. So if we give input like A, so it should always plot to B. It should never go to some other output. Then only this will define as a function. Otherwise, that would not be called as a function. Same is written over there that a relation is not a function if one input has more than one output, or two different input can have the same output, but two same input cannot have the same different output. This is example like in set R, the following coordinates are given. We can see that for the x coordinate, for single value of x coordinate, there is single value of y. So R is a function. While in S, we can see that for the value of 6, we can get two values of y, that is A and B. So it is not a function. Similarly, for T, for the value of Z, we get two values like 7 and 0. So this is not a function.
Ajay, you tell me first. You have
Yes, sir.
created contents both on function and problems, algorithms, na? Hard problems, NP problems, etc.
No, sir, we didn't cover the problem completely, but some, and sir, I didn't get the proper portion of bijection and injection with computability, but the content that I have been through from yesterday, so I have something that I have like तोड़ मोड़ के थोड़ा सा बनाया हुआ है sir, that I can explain.
समझा नहीं, एल्गोरिथम्स के बारे में आप थोड़ा सा बनाए कुछ?
So
Yes,
computability
sir.
क्या
Yes,
होता
sir.
है?
लास्ट में सर NP और NPR problems है. So लास्ट में mentioned है, शुरू में there is function and types of functions, and लास्ट में definitions है and उसके example sets हैं
आप
कुछ
थोड़ा
problems के.
स्लाइड्स को एक बार दिखाओ, नेक्स्ट करके जाओ धीरे धीरे.
Say domain range codomain. This is a test for finding a function.
Next.
Injection, bijection, type of functions. Then computability, Turing machine, फिर polynomial time problem.
अच्छा ठीक है, तो आप ये कंप्यूटेबिलिटी से आप बोलना, उससे पहले मैं थोड़ा बोल लेता हूँ फंक्शन के बारे में, ठीक है? आप बंद कर दो अभी. My screen is visible to all.
Yes, sir.
Yes, sir.
Okay. So in the last class, we have discussed these things, types of problems, and we said that there are different ways of representing a solution of a problem. We can represent using a table, which we already discussed in the previous class. So as you know that inputs, the set of inputs can be a finite set or it can be an infinite set also. But in tabular representation, only we can represent finite set inputs. So we can list the inputs and their corresponding output values. That is one way of representing the solution as a table. Other things are function and algorithm. Routine is something coding of the algorithm only. So first we'll discuss function. So as he said already that a function, what are the two essential properties of a function? First thing is that for a single input, so for a function, we have two sets. One set is called the domain and the other set is called codomain. And we use a notation something like this, f a to b, where a is the domain, the set of input values, set of all possible input values, and b is the set of, or the set where the output values can lie. Output values cannot be outside this set B. Now, the property that it must satisfy, there are two properties, one input, one output. That means there cannot be any one-to-many relationship. In DBMS, you have studied one-to-one, one-to-many, many-to-many, many-to-one, four types of relationships. But a function, so those are relationships. But all relationships are not a valid function. In order to be a function, it must satisfy this one-to-one, one input to one output property. That means, sorry, the function, the relationship may be either one-to-one or it may be many-to-one, because we are not allowing multiple outputs for a single input. So, for example, if we take the single input, single element of the domain as an input, then we must get only one output here. We should not get more than one output here. If we are getting more than one output for a single input, then that type of relationship is not at all a function. We cannot call it a function. Okay. So this is clear. So anybody, if you face any problem, you can ask me questions, because these are the very basics, fundamentals. Everything should be very clear from the fundamentals. Otherwise, later you may face problem not only in the network security course, but also in the cryptography course, and even in the next semester, if you want to take the advanced cryptography course or blockchain course, many places you will face problems. So please make your fundamentals very much clear. So the function is a kind of relationship which is either one-to-one or many-to-one for multiple inputs. For example, this input and this input, we may get a single output, the same output, but so many-to-one is allowed in a function. One-to-one, many-to-one, these two types are allowed, but one-to-many or many-to-many are not allowed. Second property says that there must be an output for every input in the domain. So for every input, for any element you take from the domain, we must get an element in the codomain. For every input, it must produce some output. So if you merge the two properties and state it in a single statement, then how can we state it? That for every input, we should get one and only one output. Or in other words, for every input, we should get exactly one, not more than one, not less than one. This is the property of a function. This is, if this is not satisfied by any relationship, then relationship meaning this table can also be considered as a relationship. For example, as the student was showing that some pairs. So for example, here 1, 1 is a pair, 2, 4 is a pair, 3, 9 is a pair. In this way, so relationship is nothing but a set of pairs. In mathematical terms, these are called ordered pairs. 1, 1, 2, 4, 3, 9, 4, 16. 3, 9 is not equal to 9, 3. So that's why it is called an ordered pair. The order is important. 3, 9. In parentheses, we write it 3, 9. So it is ordered pair. So we have how many ordered pairs here? 10 ordered pairs. 1, 1, 1, 1, 2, 4, 3, 9. In this way, 10, 100. So there are 10 ordered pairs in this relationship. So every table is a relationship. These things you have also studied in database system during your graduation. That a table is called a relation. In DBMS you have studied. Table database is a set of tables only, rows and columns. Okay. So every relationship. So if this is a relationship, then we have to test the property that for a single input, for example, here you are getting 2. Suppose this is also 2, then it is not a, here it is 2 and 4. Suppose there is another entry 5 for which this value is also 4. Instead of 25, suppose 4 is written here. That means, wrong. Instead of 5, suppose 2 is written here. That means for the same input 2, you are getting 2 different values, 4 and 25. So this can be a relationship, but this is not a valid function. Or suppose there is a value here in the output field, something 102 or 103, for which there is no input. Definitely for this particular problem that we have stated here, there will be no value because we are considering only integers. So if you consider 101 or 102 as the output, then there is no such input for which you will get the output. So that is also not, so you have to write null, like you have observed in database systems. We have to insert null for certain fields. So for a specific output, if you have the null value in the input field, then also such type of relation, that can be a relationship. That is a table, that is a relationship. No one can prevent you to create any table with any values. You can insert any values in you to create a table. That table is a relationship. But certainly all tables are not functions. Functions, two properties. For the same input, you should not get two different outputs for any input. And for every output, there must be an input. So to summarize, for every input, there should be one and exactly one output. Clear for all? I think clear.
Yes, sir.
Now, two terms, you those who have already studied or remembered is okay. Otherwise, it is a recap only. Image and inverse image in the context of function. What is an image and what is an inverse image? So this is something like an image, what you observe in a mirror. So you are the entity and you observe your image inside a mirror. So similarly, suppose this element maps to this element, meaning if we give this element as an input to the function, then suppose this element is produced as the output from the function. Or in other words, so how do we represent in another notation is that f of x in this way, f of x or f of x1 is equal to y. And this notation, fx is equal to y. So x is an element from this set domain and y is an element from this set codomain. So fx is equal to y. If fx is equal to y, here it is shown clearly. So x is this element and fx is this element in y. Then we say that this element is the image of this element. Okay, in the codomain, the element is called the image of this thing. And in other words, also you can say that this element, that means x is the inverse image of this element y or fx, whatever you say. So y is the image of x and x is the pre-image or inverse image, whatever language you use, pre-image or inverse image of fx or y. So you can get an image for a single element. Similarly, if you have a set of values, set of inputs, for example, these three values, these three dots shown here, set of these three values, that means a subset of the domain, then you are getting corresponding values in the codomain, So that subset of the codomain is also called the image of this set. Meaning, could you get, for example, if you are standing in front of an mirror, then your eye for each of your body parts, eye, nose, ear, hands, legs, you are getting images. But entirely for the entire body, also you are getting your image. The body consists of the parts. Similarly, what I am saying, if you take a subset of the domain, then the corresponding values in the codomain, the set, the subset of the codomain, which consists of the images of the values in that subset in the domain, is also known as the image of that subset. Okay. Now, types of function. There are two types of functions: spatial functions, one-to-one function and on-to function. One-to-one is also known as injective function, and on-to is also known as surjective function. So these are two different types of, this is not a classification of function. That means all functions should not be necessarily either one-to-one or on-to, but these are spatial functions. One-to-one is a special type of function. Spatial matlab kya hai? Matlab it must satisfy all the properties of a function first. Then it should also satisfy some additional properties. If it satisfies those additional properties, then we say that this is either one-to-one function or on-to function. So what are those additional properties required for one-to-one function? Injective function. It says that the function cannot be, see, the first point that I have written here is a general description of the requirement, and the second point that I have written here is a more precise mathematical definition of that requirement. So in general language, we can say this way, that one-to-one function, meaning the function does not allow the many-to-one property. Just now I mentioned that a function may be either one-to-one or many-to-one. It cannot be one-to-many or many-to-many, but it can be one-to-one or many-to-one. So many-to-one is definitely a function. But if it is many-to-one, then it is not an injective function. It is not a one-to-one function. So in order to be a one-to-one function, it must satisfy that this property that the function is not many-to-one. So mathematically, if we define this property, that means if fx1 is equal to fx2 for any two values x1 and x2 in the domain A, which is written x here, then it implies that x1 is actually equal to x2. That means, in other words, you cannot get two different values x1 and x2 in the domain for which fx1 is equal to fx2. So this is mathematical definition. You cannot get two different values x1 and x2. You cannot get two different values here for which maps to the same element in the codomain. F of x1 and f of x2 are same, and it is a many-to-one because two values are mapping to the same point. It is not allowed. So for every input value, you will get, so every input value you will get unique output value. Two input values cannot map to the same output value. Next is onto function. Onto meaning surjective also. Some people say it, call it like surjective function. Onto function meaning what? Again, if we define it in general language, then it says that there should be no element in B for which there is no input in A. Or in other words, for every element in the codomain, there must be a corresponding input in the domain. Okay. In mathematical language, you can define in this way. For all y in B, B meaning this set, A meaning this set, for all y in B, there exists an x in A such that fx is equal to y. Meaning when you give x as the input to the function, it produces y as the output. There must be one such element x in A. Okay, if we go back to that table, then let us map the requirements here into this table. 1 to 1 meaning meaning what? Suppose so it is not many to 1. So here you are getting 4 for 2. Suppose you get 4 for 5 also. Suppose the value here is 4, then it is violating the 1 to 1 property, because you are getting the same output for two different values, 2 and 5. So that means it is not 1 to 1 because it is many to 1. And the second property, on to, sorry, which one? On to, yeah. So on to meaning, did I say anything incorrect so far?
No, sir.
I don't know, maybe I have mistaken something. Even the
No,
definition
sir.
of function, maybe I have mentioned this thing, that if there is an output for which there is no input, then that is not a function, but that's not true. If there is some output for which there is no input, then it is not an onto function. It is a function definitely, but that is not an onto function. Something like I was saying, no, 101 or 102 is there and there is no input, then definitely this is a function, but that is not an onto function, because for every output there must be an input. Okay, so you are not notifying me that I'm doing mistake. That means you are not listening carefully.
Sir, it was.
Sir,
Sir,
it was a part of an injective function.
So it
sir,
is
what we can just say that there is difference between codomain and range, because other than that, if there is no
that I'm
input, how
coming
can
later.
we get an output?
No, that I'm coming later. Because no, I said codomain. No, I have not said range. I said codomain here in the definition of a function. So in the codomain, certainly for a normal function, there can be elements for which there is no corresponding
Yes, sir.
input. That is very much
Yes.
possible. Okay, only the requirement is that one input, you should get only one and only one output. Okay, anyway. So now coming to that part, range and codomain. So if you take the image of the domain, I have already defined what is the image of a subset. Now the subset is suppose the entire set domain. Now, if you take the image of this entire domain, that means only the subset of the values of the codomain for which there is an input in the domain, then that is called a range. So definitely range is a subset of codomain. And this is for a general function, for all functions. But for onto function, we have said that for every element in the codomain, there is an input, corresponding input in X. So for that reason, for onto function, range is equal to codomain. Range and codomain are not different because there is no element in the codomain for which there is no input. All of the students I'm asking, so till this point, if there is any doubt, please ask first, then I can proceed, because I don't know whether I
Sir,
could
for
explain.
1-to-1. Sir, for
Please.
1-to-1.
Please
Sir,
repeat.
for 1-to-1 function, there can be a possibility that any one of the element is not an part of an image, or that is not an image of any element of X. Then that case be a, can that case be a 1-to-1?
That case is, sir, actually 1-to-1, but it is called as into function, where the range and codomain are not seen.
I could
Sir,
not.
I can show in the PPT, sir. In the PPT, I can show this thing.
Okay, you saw.
Siddharth,
But I'll return. Okay, after you show this part only.
okay, sir. Okay, sir. Siddharth, please present the screen. So wait, sir, I can show. Okay. 6 page, 8 page, page 8. Yes, sir. Here in the 1-1 injective function, we can see every input has a one output. Okay. Then in this case, the into function is like when the codomain side has a function which has no pre-image. Like in the niche we have an example, like in the domain 1, 2, 3, we have a image as 4, 5, 6. The range and codomain are same. These are the onto function, which are many to one. And in the other example, we have 1, 2, 3, but the image side has 1, 7, which has no pre-image. And this is not equal, where the range and codomain are not equal. Then this is called the into case. This
Okay.
was the example.
Okay. So is there any other doubt of anyone? Then please let me allow. Okay. So for in one-to-one and one-to, so maybe we have confused the whole thing. So let me summarize. So for a function, the definition is that for one input, we should have one and exactly one output. If only this much is satisfied, then that is a function. No other requirement is required. Now, this essentially tells that a function can be either many to one or one to one. Now, if we exclude that many to one part and filter out only those functions which are definitely, then it will be one to one. And for onto function, we are saying that for every output, there must be an input. So that is this. Now, what is a bijective function? As it is written here, bijective function meaning injective plus surjective, one-to-one onto function. It should have the properties of one-to-one function. It should have the properties of onto function also. That means for every single input, you are getting only one output. And for every single output, you are getting only one input. For every single input, you are getting only one output. That is the property of a function, any function. But for any output, you are getting only one input. That is imposed by one-to-one property, because two different inputs cannot map to the same output. So for every output, you are getting exactly one corresponding input or pre-image. And onto meaning, for every output, you are getting at least one corresponding input. That means pre-image. So if you combine the two, then what it states? It states that for every single output in the codomain, you are getting one and exactly one input, corresponding input. Fine. So that is bijective function. The examples are shown here, the diagram. This is an example of a bijective function. This is not an example of a bijective function. Why? Because for this input, we can see there is no corresponding input. That means it violates the onto property. This is not a bijective function because for this output, we can see there are two inputs, which is not allowed because it is violating the one-to-one property. Similarly, this is violating both. This element is violating the one-to-one property, and this element is violating the onto property. But this mapping, it satisfies both one-to-one property and onto property. Okay. So again, I repeat that. So what is the observation? That for a bijective function, for every single output in the codomain, you will get only one and only one. That means exactly one input or pre-image, you can say, in the domain. That is a bijective function. Now see, let us observe. What was the definition of a function? The definition of a function said, for every single input, you should get exactly one output. Now, what the bijective function definition is saying? Bijective function definition is saying that for every single output, you are getting exactly one input. So see, observe that this definition is exactly the opposite of the definition of a function. Bijective function definition actually is the opposite, is imposing the opposite thing of the requirements of a function, definition of a function. Definition of a function said that for every input, you should get exactly one output. And definition of bijective function imposes that for every output, you are getting exactly one input. That means if we change the order, that means if we make the codomain as the domain, and if we make the domain as the codomain, that means if we reverse the arrows, then certainly that indicates the existence of a different function, another function. Could I explain to all? The definition of a function says that for every element in this set, we should get exactly one element in this set. If it is satisfied, then there exists a function from A to B. Now we are saying that for a bijective function, for every element in this set, we have exactly one element in this set. That means from this to this, from this side to this side, there exists a function. And this function is called the inverse function. So the importance of bijective function is that the property bijective function property ensures that there must be an inverse function. There must exist an inverse function for this particular function if it is a bijective function. If it is not a bijective function, then the inverse function does not exist. If a function is not bijective, then the inverse function does not exist. Can anyone explain this statement that if the function is not bijective, then the inverse function does not exist from this figure, what is now being displayed in the slide?
Hello, sir.
Please.
So we have to explain if a function is not bijective function, then it would be not a function, right?
Then inverse cannot exist. This you have to establish.
Okay. Like, sir, in the first one, that is not the bijective function. So, like in domain, A have its image in codomain like 1, and B have its image 2, but 3 not having its any pre-image in domain A, right? So if want to reverse this function, then suppose that 1 will make its image as A and 2 B, but 3 will not make any image. So according to the definition of function, there should be any image in codomain, sir.
Right, you were.
So here the element 3 violating the property of function, sir.
Exactly, very good. And for the second figure, this one?
Like for element 2, it's having two images like B and C. So it's again violating the property of function, sir.
Exactly. So as he has explained very clearly that if it is not bijective, if it is not a bijective function, then this is either the case this one or the case this one, or it can be both. Now he has analyzed nicely for this case 1 and case 2. This is case 1 and this is case 2. So consider first case 1. So you are reversing the order, making B as the domain and A as the codomain. Then these are inputs and these are outputs. So this particular input, now this is acting as the input, not output. So when you give 3 as the input, there is no output because there is no corresponding element in A. This violates the definition of a function. For every input, we must get an output. ऐसा नहीं है कि 1 के लिए आउटपुट मिल गया, 2 के लिए आउटपुट मिल गया, 4 के लिए मिला, 3 के लिए नहीं मिला तो क्या है? नहीं, ऐसा नहीं हो सकता. For every input, you must get an output. That's why you cannot define any function mapping from B to A. So here you cannot define any function from B to A. Similarly, in the second case, if you take this element 2 as the input, you see you will get two outputs. You will get two outputs, B and C. This also violates the definition of a function, which says that for every input you get exactly one output, not more than one. So this also violates. For some elements it violates. That means it violates the definition of a function. So you cannot get any function from B to A. And in this case is a combination of both. So this violates both. So only for a bijective function, the inverse function exists. Okay. Bijective function, you see, bijective function can also be viewed as a permutation if either of the domain or the range, the values are natural numbers, 1, 2, 3, 4, etc. Okay, because then in that case, for example, here the range is a set of natural numbers 1, 2, 3, 4. In that case, every element uniquely will map to some number. That means it will assign, for example, A, B, C, D, these are the student names of the students, and 1, 2, 3, 4, these are the roll numbers. So every student is uniquely mapped to some roll number. So automatically the this is an order. Suppose we are assigning the roll number according to the marks obtained by the students. So maybe in the next semester the order may change. So this snapshot shows one particular permutation, that A is coming, who is coming first? B is coming first, C is coming second, A is coming third, and D is coming fourth. So this is one permutation, B, C, A, D. So if you change the arrows, another permutation can be. So this way, if the the domain is the set of natural number, then that indicates a permutation of the elements in the codomain, the range. Okay. So graphically, if we want to state the condition in this way, as it is written here, that if you plot the graph of a function x versus y, if you plot it in the graph paper x versus y, then if you draw a horizontal line, anywhere, horizontal line meaning parallel to the x-axis in this graph anywhere, then it must cut the graph, intersect the graph exactly at one point. That means two things it is stating, that it must intersect the graph somewhere, it must cut the graph somewhere. And second thing is that it must cut the graph exactly at one point, not more than 1 point, not less than 1 point. Then only it is a bijective function. Why? Suppose if we draw a horizontal line, and for example, in this figure, if we draw a horizontal line and for this graph, this particular graph, it cuts at 2 points. Then this particular y value, see here, set of all x values constitute the domain, and set of all y values constitute the codomain. So for this particular value in the codomain, y value, this height of this green colored horizontal line is the value of y. You are getting two different red points, two different values of x, this value and this value, two different values of x you are getting. So one particular output, you are getting two different inputs, which is not allowed in a bijective function. One particular output, you should get only one input. That's why we are saying that when you draw a horizontal line, that horizontal line meaning that indicates a particular value of y, we should get exactly one value of x. We should not get more than one. And second thing is that it should cut the graph somewhere. For example, even it is violating the other property. For example, if you draw the horizontal line here, it will not cut the graph anywhere. So that particular value of y, or for example, suppose this part is not present in the graph and the graph starts somewhere here, in this way the graph goes. Then if you draw a line here, then it will not cut the graph. And then for that particular value of y, there is no value of x, valid input for that corresponding, for that particular function. So that means it violates the onto property. In that case, you have to define precisely what is the range of the function. or what is the codomain of the function. Because for a bijective function, the range and codomain should not be different. For example, if it starts, suppose this negative part of the graph is not present here. Suppose I delete this negative part of the graph, okay, below x-axis line. So then in that case, if you draw a horizontal line here, it will not cut the graph. So in that case, can we say that it is a bijective function?
Sir, it cannot be a onto in that case.
This actually depends very much on the definition of the codomain, definition of the domain and codomain. That means what I'm saying, if I do not allow x to be less than x, less than 0, sorry, y to be less than 0, then you cannot draw a horizontal line here. No? If I strictly define the codomain that it is positive, something greater than equal to 0, because that is in my hand, the function is same, but I can define the domain and codomain. If I define that y must be greater than equal to 0, then you are not allowed to take any value of y less than 0. In that case, definitely whatever value of y you take, you will get a corresponding value of x. That's what I am saying, that whether it is a bijective function or not, that not only depends on the function, but also the way that you are defining the function, domain and codomain. Another example I can give, for example, suppose the codomain and domain are not continuous, they are discrete. Then if you draw a line somewhere in between 2 points in the y-axis, discrete meaning there are discrete points in x-axis and discrete point in y-axis. Now you intentionally draw a line in between 2 points, then suddenly you may not get any value of x. But you are not allowed to draw such a line if I define clearly the set, that this is the set of codomains, because I can define what is the codomain. If I say that the codomain is any real value greater than equal to 0, then you cannot prevent someone from drawing a line, horizontal line at any point in y. But if I clearly define that it is, suppose, for example, it is a set of natural numbers, then someone cannot claim that I have not obtained any value for this particular value of y. Okay, clear? Okay. So what is an inverse function? So inverse function meaning a function, let us suppose let us denote it by the letter g, like we are using the letter f. So the inverse function says that if f of x is equal to y, then g of y must be equal to x. This should be true for all x belonging to A and y belonging to the codomain B. Okay. So G is another mapping. G is the inverse mapping, inverse function. Okay. So the requirement is that you give any input x from the domain to the function f, and if you get the value y, then that y, if you pick and put here as the input to the function g, then it must produce back the same result x, what you have used as the input in x. If it satisfies this property for all values of x in A, then we can say that G is the inverse image or inverse function of x, f. Now, usually we do not use two different letters f and g. Instead, we use this notation f inverse. This is called f inverse. This is just a notation. In place of g, we are using the notation f inverse. This is the symbol, but this is nothing but a function. So remember that this is a function, like g of y also you can write. There is no bound that you have to write f inverse. You can say that g is the function, inverse function. So g is a function. Remember, g is a function. G and f are not the same function. Okay. So far, is there any doubt or everything is clear? So this is f mapping from this set to this set, and this is f inverse mapping from this set to this set. So this is f x to y. F inverse maps the reverse thing. Again, please ask.
Is it okay to say derivation and integration are the inverse of each other?
Please be louder a little bit.
So is it okay to say derivation and integration are the inverse of each other? Inverse function.
Derivation and
Integration.
is what? Differentiation you are saying?
Yes, a differentiation. Derivation.
Differentiation and integration you are asking.
Yes, sir.
Maybe that depends on, again, how are you defining, whether it is that integration is that finite integration or infinite integration. Many things are there. Okay.
Okay. Okay, sir.
So what I am trying to highlight is that this f and f inverse are not the same function. Okay, you can represent it using a different letter g also. I am giving one concrete example. For example, a simpler example than your differentiation or integration. Suppose square and square root. So if f is the square, function square, in C, in programming language C, you have already implemented the square, square root, factorial, many things you have implemented in C. Suppose somebody has told you that you write a program to calculate the square of a function. You cannot suppose use the math.library, math.h library. So using simple loops, etc., if else, you have to construct the logic. So you can write this function to calculate the square of a function, square of a given integer. So this is suppose f. Then if somebody tells that write the inverse function now, then you have to write a function called sqrt. Now think about the body, meaning the logic of square and square root. How would you write the code inside that function for a square function and for a square root function? How do you calculate square root? Do you remember the algorithm? Just think, you don't have to tell. And what is the logic? You know that calculating square is much easier in the sense, not time complexity for a human being. The logic is very simple. Just multiply it, this thing 2 times. Meaning multiply the number by the same number. That's it, all square. But square root, you know that algorithm, even if I instantly tell you, many of you may not be able to do that thing without using any math.library. Okay, so this shows what? That f and f inverse are not the same algorithm. Okay, that's what I am highlighting, that the inverse function is not just inversing the domain and interchanging the domain and codomain. Of course, you are interchanging the domain and codomain. Domain is becoming codomain, codomain is becoming domain. But that's not all. The functions are completely different. F is a different function, and f inverse, which you also can say g, h, any letter you can use to denote that function. But that function is a completely different function. The algorithm, logic, everything, the code that you use inside to implement that thing is completely different. In special cases, in some cases, inverse of a function may be the same function. That is different thing. But in general, like in the example of square and square root, I said the functions are different functions, different logic, different algorithms, different flowcharts you have to use to implement f and f inverse. This point is clear to all?
Yes, sir.
Okay, now just before going to the computational problems, let us also, for the sake of completeness of discussion, this is also very much important. You will observe such type of functions. So far, we were discussing about unary functions. Unary function meaning unary, binary operator, etc. You have studied in C, so you are familiar. Unary operator takes one input. Binary operator takes 2 inputs. And n-dimensional operators also available, which can take n inputs. So like the diagram shows here, that a binary function takes 2 inputs x and y and produces something x o y. This o stands for the operation. This o, you can replace this o by a plus symbol. You can replace this O by a minus symbol, a multiplication symbol, a division symbol, a module symbol, meaning which calculates the remainder mod, or any power symbol, power x to the power y, x log y, whatever, or any binary operator, anything you can design of your own function. Also you can design. X and y are two inputs, and that O stands for the operation. And we also now we use these notations to represent a binary function. F is a mapping from x cross y to z, x cross y to z. That means this thing only, the same thing, that F takes two inputs, one from x, the set x, and another from the set y, and it produces this some element which lies in set z. And we also use this notation that if, like in the unary case, we use fx is equal to y. In this case, we use the notation f of x y is equal to z for all x in x and for all y in y. This is clear. All of you have started this thing. Now, a question you can observe here. What is the domain of the above function? Can anyone tell me? What is the domain for this binary function f? This. Anyone, please?
So maybe the values of x and y which we input.
I want a more mathematical answer.
So
Definitely, we're taking a value. Sorry.
Set x will be the domain.
Set x will be the domain. Then there is
all the possible outcomes of x multiplied by x dot y.
X dot y meaning
Domain.
X operator y.
Yeah,
X
x
operator
operator y.
See, you are taking, actually, what is your input?
X and y.
This is
Order
like,
pairs of x and y, sir.
this is something like this.
Sir, all order pairs of x and y.
You are taking one element x from this set, and you are taking one element y from this set. These two inputs you are taking, one element x from small x from x and small y from y. And then you are operating, and then you are producing one element z into belonging to z, capital Z. So what is the input?
Sir, order pairs x, y.
Yeah, the ordered pair x, y. X comma y, as I was mentioning earlier in the parenthesis, x comma y. This is the ordered pair. This is one sample input. So this is one sample input. Then what is the domain? Domain meaning what? Domain meaning all possible inputs. A small x comma small y within parenthesis is a sample input. So all possible inputs meaning what? See, I have highlighted using the two different colors, red balls here in X set and green balls here in Y set. So you take one red ball, any one randomly, or you can select sequentially also. One red ball you pick from a set X, and then any green ball you can pick from set Y. So how many possible inputs are there? How many possible inputs will be there?
Sir, x, y.
XY meaning?
X into y.
What is X and
Cross product. So cross product of x and y. Cross product of x and y.
The number of elements.
This is the size.
Elements in
X union y.
What are you saying? I'm not getting. X cross product Y is the size of the domain?
Sir, I think x to the power y.
No. Why it should be? You can count
For
the
every
balls.
element, we can map it to.
Suppose how many balls are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here we have 1, 2, 3, 4, 5, 6, 7. Here we have 10 red balls and 7 green balls. Then tell me how many possible inputs you can create.
70.
70 inputs. Because see, the first input always should be from X. And the second input should be always from Y, because it is an ordered pair. You cannot pick green ball first and then you cannot place green ball first and X red ball in the second place, because we have said that X, the notation, then if you want to use that thing, then it will be F Y cross X. Okay, since it is X cross Y, that means the first input is always from X, second input is always from Y. So if you take one ball from X red ball, then you have 7 options from Y. So in this way, 10 red balls are there, 10 into 70, 70 possible inputs are there. And each input is an ordered pair, small x comma small y. So if I list it, if I create a set, okay, write it as a set of all 70 ordered pairs, all 70 ordered pairs, then what it is called? A Cartesian domain. This is called a Cartesian product. Okay, so the answer is, the domain of the function is Cartesian product between x and y. Okay, those who have forgotten what is a Cartesian product, this is a quick recap. You can just look into the figure. So there are two sets, A and B. A is consisting of two values, 1 and 2 integers. B is consisting of 3 characters, A, B, C. So the Cartesian product is in this way. So there are 6 elements. So see, there are 6 ordered pairs. So if I just write it as a set format, in a set format, then this is a set of 6 elements. So you can take any of these elements, 6 elements, as the input, and you can produce one output belonging to Z. So this is a binary function. In the same way, you can also you can n array, meaning n number of inputs you can take and define a function. So if from x1 cross x2 cross x3 dot 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 cross xn to mapping to y, n-dimensional or n-array function. Now all the definitions we have discussed earlier, into onto function, one-to-one function, bijective function, inverse functions, are all applicable to n-array function also. Similarly, they are applicable to all types of functions, not only unary function. They are applicable to binary or any n-array function. I think up to this point, if there is any doubt, you can ask me. There is no question. So again, coming back to this point. Okay, so bijective function ensures that there exists an inverse function. Inverse function is a function that is not the same as the function, not only just that you are interchanging the domain and codomain, the logic inside those functions, the algorithm, the flowchart that you use inside those functions are also completely different. In general, they may be same in some special cases. Up to this point is very much clear, I think. Now the question may be coming to your mind, why we are discussing all these mathematical things when we are studying cryptography or network security. Actually, in the introduction to cryptography classes, I have told you, if I go back to that slide, let me go back. See, when we were discussing this encryption, decryption, digital signature, etc., what we were saying, some security requirements we were stating something like this: given the ciphertext and the plain text, the adversary should not be able to calculate any bit of the encryption key. Or given the ciphertext, the adversary should not be able to get any bit of the plain text without knowing the encryption key. Such type of things. I forgot to mention the requirements for digital signature. Digital signature also similar requirements we have. For example, without having the proper private key, no one should be able to create a valid signature. Valid signature meaning which will pass the verification test. So such type of requirements when we are discussing, these are security requirements. Now, how can you prove or how can we analyze such security requirements? For example, if I say that given the ciphertext to whom? To the adversary, and the plain text, the meaning ciphertext and corresponding plain text, the adversary should not be able to generate the encryption key. I mean, to get any bit of the encryption key. Now see, encryption is a function. Encryption is an algorithm, meaning what? Encryption is a function, f. And C is nothing but f of m and key k. Like f of xy is equal to z, we were calculating. So we can say C is equal to f of m comma k, a binary function. Now, this you are telling to the, giving the information to the attacker. This information you are giving to the attacker, whether the adversary should be able to calculate the encryption key or not. This is what type of problem now in the context of the discussions that we have made so far regarding functions. What type of problem is this?
Sir, finding inverse.
Finding inverse. Suppose you are the attacker. Suppose you are the attacker. So you are given the plain text, you are given the ciphertext, encryption algorithm is also known to you. Additionally, if you want the decryption algorithm, that is also given to you. But you have to calculate the encryption key. So this is the inverse, calculating inverse of a function. Okay. Now, if the adversary is able to calculate the inverse, then the algorithm is not secure. Encryption mechanism is not secure. Otherwise, it is considered secure. Right. So that's why it is very much important that we first understand this thing. First, we have defined what is an inverse function. Now we'll see whether inverse calculation of inverse is how much difficult for some problems. Or is it difficult for all problems? Or is it difficult for no problems? Or is it difficult for only some problems? Which type of problems then? Because we want this inverse to be very difficult. Adversary should not be able to compute the inverse thing. It should be very difficult. But one thing also you observe that f inverse should be difficult, this we have identified. Whether f should be difficult or not in this context, whether f should be difficult or not. If you say that encryption is f.
No sir, f should not be difficult.
Why?
Sir, it will increase the cost.
Otherwise, how the sender will encrypt? Sender must be able to encrypt, because I assume that sender is also a computer, attacker is also a computer, receiver is also a computer. And let us assume that all computers are having the same capacity, same processor, same RAM, everything. So if it is difficult for the attacker, then it is difficult for the sender also. Okay. So if encryption algorithm itself is a difficult algorithm, then sender cannot encrypt it. Difficult meaning it cannot do this thing. Or similarly, if the decryption algorithm is difficult, hard, then the receiver cannot decrypt it. So neither the encryption algorithm nor the decryption algorithm should be hard. This should not be. Now, what is the meaning of hard, difficult, etc.? Now will be explained by you. But those should not be difficult. However, the inverse problem must be difficult, hard. Okay. So what is hard problem, etc., we are coming later. But so far I have discussed what is an inverse problem. Calculate the square root. If calculating the square is a problem, then calculating the square root is the corresponding inverse problem. Okay. Now coming to the next question, that forget about inverse or forward problem. Let us consider a problem, and again going back to the beginning, that a problem which you have represented using a function. Now whether it is a hard problem or not hard problem. Okay, whether it is a hard problem or not hard problem, how do you define it? Now, just now, one of you said that the computation cost should not be very high if it is not a hard problem, and the computation cost must be very, very high. Last classes in cryptography also we have discussed this thing. If we want that some problem to be hard, for example, we want that f should not be resource consuming, f should not be time consuming, computation cost consuming. However, f inverse must be consuming a lot of computation resources, maybe in terms of memory, maybe in terms of usually it is in terms of computation time. So that indicates the basics of an algorithm, computation cost analysis, which I think all of you or most of you have studied during graduation algorithms course. In algorithms course, you have studied how to analyze the time complexity of an algorithm. So we want that f inverse should be complex problem, more complex problem, and f should not have more complexity. Now, what is more complex and what is less complex? These things also you have studied complexity classes. Any algorithm can belong, any algorithm you can write. Now the time complexity, either you can represent the time complexity in absolute terms. For example, you run the algorithm in a specific hardware and measure the time, how many milliseconds it took, and in that term you can see. But that becomes very much hardware dependent. But we want something which is hardware independent. So we count this number of CPU cycles. Number of CPU cycles it will consume to execute that particular algorithm. And that depends on the number of operations, number of iterations you are performing, etc., etc. And you know how to analyze the time complexity when you write an algorithm. How many operations will be performed in terms of input size. Definitely, when you increase the size of the input, certainly the cost will increase. So what is the relationship? What is the function that can represent the relationship between the cost of an algorithm in terms of time complexity and the input size? Now, you please discuss more on this computational problems. Somebody, you started, please continue. Please start that group wanted to start the discussion on computational problems.
Hello. Yep. So talking about the computability, what is computability basically? When we pass when we pass a task to an algorithm, whether that algorithm will be able to tell us that the result will get the result or not, we can define computability as this. Talking about for example, we can talk about the Turing machine. In Turing machine, there are three states that for a given problem, it will say yes, or Turing machine will halt, saying that this this problem is solvable, or Turing machine will stop on a state where it will say that the problem is not solvable, or Turing machine will go into an infinite loop where we cannot conclude whether it is an infinite loop or it might stop in the future. For example, when we check if expression a to power n, b to power n is a regular expression or not. So it will definitely start at a state where it will say yes, it is a regular expression. And when we pass equation a to power n, b to power n, a, asking whether it is regular expression or not. So it will go into the state when it will say no, it is not a regular expression. And if you want to count the number of digits in the pi, so it will go into infinite loop because number of digits in the value of pi is infinite and they are not countable. So it will come under the third state, that is halting problem. This will explained by the Manav or Anshul.
Yeah, thanks, Siddharth. So we can see that we can broad classify the problems into two types, that is decidable problems and undecidable problems. So what are decidable problems? That if there exists a algorithm to solve that problem, we call that problem decidable. And if there does not exist any algorithm to solve the problem, we call that problem undecidable. So in decidable problem, we also have two classes like tractable problem and intractable problems. So what are tractable problem is that if we solve that problem in a polynomial time, we call that problem tractable, and simply intractable is the reverse of this. So what P class problem is that if any given problem can be solved in a polynomial time, we can it comes under the P class problem. That we can see that if the complexity is big O of n to the power k, where k is some constant, like such that there exists a polynomial P such that the execution of algorithm A on any input of size n always terminate in P or fewer steps. We call this in polynomial time problem class. Also we have
नहीं यहाँ मेरा क्वेश्चन है कुछ, आप पहले बताओ व्हाट इज द पॉलिनोमियल.
So polynomial is like we have an expression like x to the power k, where k is a constant. Like we call it polynomial.
What is the generic equation of a polynomial? I'm
Like,
asking to all the students. Anyone can answer. What is the generic equation of a polynomial?
Hello.
Bolo.
Yes, sir, like x to the power 0 plus x to the power 1 plus x to the power 2, then 3 up to n, and n maybe any integer number.
Coefficients भी बताओ साथ में coefficients भी बताना चाहिए ना. A0
yes, sir.
plus
Like
A1
we
x
can
to
add
the 1 plus A2 x to the power 2,
yes,
है ना, ऐसे करके
yes,
A next to the power n is a this is equal to y. This is
yes,
a polynomial equation, or if you simply say fx is equal to this, then this is a polynomial of x, where x is the input. Okay. Now you tell me what is a polynomial time algorithm. So this is a polynomial. Now what do you mean by a polynomial time algorithm? Meaning clearly you specify. Explain.
so like the algorithm which can be computed in a finite number of steps.
नहीं आप तो उसका significance meaning बता रहे हो. Just definition मतलब mathematically.
So in terms of example, when we talk about the tower of Hanoi, if you don't use memoization or dynamic programming, then it is a problem of polynomial time complexity, that is power n.
So this basically means the runtime complexity should be a polynomial, like order of log n square, n plus log n example.
Basically, n to the power k.
N to the power k.
K, where yes, where k could be an integer, positive integer.
n क्या है?
Sir, n sir, size of the input, I think.
Size of the input.
Yeah.
कैसे इसका मेजर करते हो? यूनिट क्या है इसका?
Size of the input.
अरे आप मेरे सामने ही सर्च कर रहे हो, आपका स्क्रीन शेयर है.
सर वेरिएबल है एक्चुअली.
क्या है?
सर एक्चुअली सर वेरिएबल आंसर इन इट्स यूनिट. सर यूनिट इट्स unit is unit only.
यूनिट इज यूनिट।
Yes, sir.
अरे साइज
I
होगा,
mean,
का साइज होगा तो कंप्यूटर साइंस में साइज ऑफ द डेटा किस में मेजर करते हैं?
बिट में, बाइट
बीट
में
में,
सर।
नंबर ऑफ बिट्स, साइज इन नंबर ऑफ बिट्स। आप लोग ये मत सोचना कि एल्गोरिथम में जैसे पढ़े होंगे कि सॉर्टिंग एल्गोरिथम, सर्चिंग एल्गोरिथम में देखे होंगे नंबर ऑफ एलिमेंट्स इन द एरे, ऑर्डर ऑफ n वहां पे बताया जा रहा था ऐसे, बट दैट इज नॉट ट्रू फॉर इन जनरल एल्गोरिथम एनालिसिस। इट इज एक्चुअली साइज ऑफ इनपुट। अगर आप साइज ऑफ इनपुट कांस्टेंट हो गया देन दैट बिकम्स प्रोपोर्शनल टू n, but sometimes different size in particularly in cryptography the size of input is also a variable. Meaning size of data, sorry, size of data is also a variable. For example, in an encryption algorithm you use different keys of different sizes. आप जब सेट ऑफ इंटीजर लेते हो सॉर्टिंग करने के लिए तो एक एक इंटीजर 4 बाइट ही होता है, या फिर 4 बाइट्स या फिर 8 बाइट्स होता है, तो वो कांस्टेंट है. So number of bits is proportional to number of elements in the array, but that is not the case in case of cryptography, because in cryptography plain text is a different input, key is a different input, and each input may have different sizes. For example, one algorithm uses 64 bits key, one algorithm use 128 bits key. So in general you have to mention the total size in number of bits. अगर आपके पास 3 इनपुट है तो तीनों इनपुट का मिला के कुल मिला के कितना साइज हो रहा है टोटल, सो इन नंबर ऑफ बिट्स, दैट इज योर क्या कहता है, साइज ऑफ द इनपुट. सो usually we use the notation k in cryptography to denote the size of the input, k. Okay, and if your then you analyze the time complexity of some algorithm. So if it is coming as k, order of k, BIGO, I know asymptotic notation, BIGO, all these things I think you already know. If you do not know, then please revise asymptotic notation, how to analyze the time complexity of an algorithm. So if it is coming as O of k square, O of k log k, etc., k cube, k to the power 4, anything, then we say that this is a polynomial, because this is a polynomial of k, so it is a polynomial time algorithm. ठीक है, अगर आप बताओ फिर, अगर ये अगर polynomial time है तो polynomial time कौन सा नहीं है, मतलब टाइम कॉम्प्लेक्सिटी क्या होगा, क्या होने से आप कहोगे कि दिस इज नॉट अ पॉलिनोमियल, है ना. इनपुट साइज अगर k है तो k स्क्वायर, k log k ऑल आर पॉलिनोमियल. तो एक कुछ फंक्शन बताओ इन टर्म्स ऑफ k जो पॉलिनोमियल नहीं है.
2 की पावर n,
तो 2 raised to x raised to
k
something.
k raised to power n, मतलब any constant raised to the power variable n.
आप लोगों को मैं बता रहा हूँ इनपुट साइज k है, n कहाँ से आ रहा है.
तो ऑर्डर ऑफ k का फंक्शन कोई भी रहेगा वो तो नॉन पॉलिनोमियल ही रहेगा ना.
देखो एक पॉलिनोमियल जब आप डिफाइन करते हो, अभी अभी आपने बताया ना fx इज ए पॉलिनोमियल फंक्शन ऑफ x. कब उसको पॉलिनोमियल कहोगे कि fx इज इक्वल टू a0 प्लस a1x प्लस a2x प्लस a2x स्क्वायर प्लस डॉट 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 an x टू द पावर n. n इज नंबर ऑफ टर्म्स इन द पॉलिनोमियल, है ना. तो यू डिफाइन द पॉलिनोमियल इन टर्म्स ऑफ x, पॉलिनोमियल ऑफ x. जैसे आप यहाँ पे लिखे हो स्लाइड पे, जैसे लिखा है पॉलिनोमियल ऑफ n, दैट मींस अ फंक्शन व्हिच इज अ पॉलिनोमियल फंक्शन ऑफ द इनपुट साइज n. ठीक है, और मैं कह रहा हूँ n मत बोलो उसको, n एल्गोरिथम में यूज जब आप किए हो, गूगल बबल सॉर्ट, ये सब सॉर्टिंग सर्चिंग करने के लिए नंबर ऑफ आइटम्स को आपने माना था इनपुट, लेकिन यहाँ पे नंबर ऑफ बीट्स को आपको मानना है इनपुट. तो आप बोलो k के टर्म्स पे, k के टर्म्स पे अगर बोलोगे तो वो होगा ऑर्डर ऑफ k स्क्वायर, ऑर्डर ऑफ k log k, ऐसे. कोई कंफ्यूजन है?
नो सर.
नहीं है ना.
नो सर.
हाँ, देन आप बताओ कि एक इक्वेशन बताओ इन टर्म्स ऑफ k जिसको आप कहोगे कि दिस इज नॉट अ पॉलिनोमियल.
सर फैक्टोरियल के
हो सकता है। और कुछ
some constant to the power k.
2q
से
और k।
एक्सपोनेंशियल
नहीं, इक्वेशन
2 to the power k और some constant to the power k
2 to the power k, constant to the power k, right? These are not polynomial. These are what?
Exponential.
Non-polynomials.
Exponential. These are exponential functions of k. 2 power k is a exponent. माने आप x एक्सिस में k को पुट कर रहे हो, y एक्सिस में f of k पुट कर रहे हो, f of k, function of k. This f is actually the time complexity. This f function actually represents the time complexity of the algorithm. f of k. Now f of k is equal to 2 power k. मतलब ये दिखने में कैसे होगा? विजुअलाइज करोगे तो कैसे दिखेगा?
say it will look like e to the power x like that or e to the power x
हाँ, तो वो कैसे दिखेगा?
it will
Increasing function.
increasing function
पैराबोला या
सर,
फिर
it will
जैसा दिखेगा,
Parabola.
है ना?
Yes, sir.
हाँ, तो वो सब है एग्जांपल एक्सपोनेंशियल। यूजुअली एक्सपोनेंशियल फंक्शन ऐसे पैराबोला जैसे दिखता है, तो वो हो गया। और बाकी अगर मतलब अगर एक शॉर्ट हैंड रूल बताया जाए तो जो पावर है वो पावर में अगर k आ गया तो दैट इज एन एक्सपोनेंशियल फंक्शन। अगर पावर में k नहीं है देन इट इज, ऑल्दो दिस इज नॉट अ वेरी गुड मैथमेटिकल डेफिनेशन, बट याद रखने के लिए ये आप याद रख सकते हो कि अगर पावर में k आ गया, 2 पावर k हो चाहे कोई कांस्टेंट पावर k हो, फैक्टोरियल k को भी एक्चुअली आप कन्वर्ट कर सकते हो उसी फॉर्मेट में। स्टिरलिंग्स अप्रोक्सीमेशन देख लेना क्या है, तो उसी फॉर्मेट में ही चला जाएगा वो भी। एक्सपोनेंशियल फॉर्मेट इसको कहते हैं क्योंकि एक्सपोनेंट में आ रहा है कि। और एक चीज है कि ये पावर में एक्सपोनेंट में अगर के की जगह लॉग के आ गया ना, लॉग के, फॉर एग्जांपल 2 पावर लॉग के और c पावर लॉग के, e पावर लॉग के, दीज आर कॉल्ड सब एक्सपोनेंशियल्स। क्या कहते हैं इसको? सब एक्सपोनेंशियल। ठीक है, लेकिन सब एक्सपोनेंशियल इज नॉट आल्सो पॉलिनोमियल। पॉलिनोमियल में पावर में कुछ भी, एक्सपोनेंट में कुछ भी के नहीं आना चाहिए, के नीचे रहेगा। पावर में कांस्टेंट रह सकता है 2 3 4 5 सी डी ई कुछ भी रह सकता है, लेकिन पावर में के वेरिएबल नहीं रह सकता। नीचे रहेगा के कुछ भी चाहे लॉग के हो, के टू द पावर 2 के कुछ भी हो सकता है। तो दैट टाइप ऑफ फंक्शन इज पॉलिनोमियल फंक्शन। अब ये बताओ कि पॉलिनोमियल फंक्शन, हाँ आप कुछ बता रहे थे एक्चुअली, आपका नेक्स्ट स्लाइड में जा सकते हो अभी, प्लीज गो अहेड।
Yeah, Manav will continue.
Okay, next slide, please. Okay, next slide. Yeah, these were some samples. As the sir said that as sir defined the polynomial equations. So most of the sorting that we have studied, like mouse short, quick short, they all are in the time complexity of all are in the polynomial form. So these all problems come under the polynomial time problems. Next slide, please. Next slide. Okay, now the second part is non-deterministic polynomial time problems. The class of decision problems that are solved in polynomial time on a non-deterministic machines. So what are non-deterministic machines?
मैं आपको इंटरप्ट कर रहा हूँ यहाँ पे। आप नॉन डिटर्मिनिस्टिक पॉलिनोमियल जाने से पहले एक्चुअली आपको यही से आना चाहिए था। अच्छा, मैं सभी स्टूडेंट को पूछ रहा हूँ, आस्किंग टू ऑल द स्टूडेंट्स, किसी को अभी तक यहाँ तक किसी को डाउट है कि पॉलिनोमियल टाइम एल्गोरिथम क्या है? एक एल्गोरिथम को पॉलिनोमियल टाइम कब कहोगे? कोई डाउट नहीं है ना? फिर से मैं बता रहा हूं कि साइज ऑफ द इनपुट आपको कैलकुलेट करना होगा इन टर्म्स ऑफ नंबर ऑफ बिट्स, जितना भी टोटल इनपुट है, और उसको अगर k मानते हो कि k रिप्रेजेंट्स द साइज ऑफ द इनपुट इन नंबर ऑफ बिट्स, देन यू कैलकुलेट द नंबर ऑफ CPU साइकिल्स रिक्वायर्ड to perform your execute your algorithm in terms of k as a function of k, f of k. If this f of k is a polynomial function, then your algorithm is a polynomial time algorithm. Otherwise, it is not a polynomial time algorithm. अब polynomial function क्या है वो तो मैंने बता दिया, मैथमेटिकल डेफिनेशन है बहुत बड़ा, लेकिन याद रखने के लिए सीधा तरीका ये है कि जो फंक्शन आ रहा है वहां पे पावर में, एक्सपोनेंट में कहीं पे अगर k नहीं है तो वो पॉलिनोमियल टाइम फंक्शन है. अदरवाइज इट इज नॉट लाइक 2 पावर k, c पावर k, e पावर k, कुछ भी हो. These are not polynomial time function. ठीक है, सॉरी, polynomial time. These are not polynomial time functions, so the algorithm is not polynomial time algorithm. आप अगर समझे हो तो एक बताओ कि लास्ट क्लास में we have observed the brute force attack, है ना, कि you have a k bit key, k bits key, ठीक है. The size of the key is k bits, suppose, encryption key, which you use to lock your ATM card. Now the adversary has got access to your ATM card and trying random keys. Okay. And he is using an exhaustive search. That is, he is trying all possible keys one by one. All possible keys one by one. And suppose there is no limit. Unlike that you have maximum 3 retrials you can do. No, there is no such limit. You have infinite limit. There is no limit actually. So he is trying all possible keys one by one, starting from all 0 to all 1, the key bits. This is the algorithm used by the attacker. Remember, attacker is an algorithm. Attacker is an algorithm. Attacker is a computer and attacker is an algorithm. So he is using this exhaustive search algorithm. Now, what would be the time complexity of this algorithm?
So 2 to the power k.
Bigo notation पे बताओ, order of क्या होगा? O of
order of constant to the power k.
What is the constant?
2.
Sir, number of digits.
2.
सर मतलब अगर
Zero
की
and
सर न्यूमेरिक है तो
1
0 से
0
9
2. ओके ओके.
दूसरा कोई कुछ बता रहे थे आप?
Yes, big O of 2 to the power k. Here each bit.
This is correct answer. आप explain कर दो खाली.
Yes, for each bit it will be either 1 or 0. So for each number of bits, so there are 2 possibilities. As there are k number of bits, so for total there will be 2 to the power k combinations.
2 power
सर
k.
मैं उसको न्यूमेरिक में ले गया, बाइनरी की जगह. मतलब डेसिमल में ले गया, मतलब 0 से 9 कंसीडर कर रहा था मैं हर स्पॉट के लिए. हाँ, मतलब बाइनरी होना चाहिए था.
हाँ, तो ठीक है ना, मतलब क्लियर ना कि O of 2 power k हो रहा है. और वो सब आप देख लेना, मतलब बिगो नोटेशन कैसे मतलब कैलकुलेट करते हैं. अगर हायर कुछ ऑर्डर रहेगा तो लोअर ऑर्डर ऑटोमेटिकली चला जाता है वहां पे एक इक्वेशन पे. अगर एक्सपोनेंशियल कुछ टर्म रहेगा तो जो नॉन एक्सपोनेंशियल टर्म है उसको आप हटा सकते हो. अगर ऑल टर्म्स आर नॉन एक्सपोनेंशियल तो वहां पे जो लार्जेस्ट टर्म है, फॉर एग्जांपल k to the power 5 है तो k to the power 4 को आप हटा सकते हो, k to the power 3 को हटा सकते हो. ऐसे करके रिडक्शन कैसे करते हैं बिगो नोटेशन पे देख लेना. तो अगर कोई एक्सपोनेंशियल टर्म है तो बाकी ऑपरेशन आपको देखना ही नहीं पड़ेगा उस एल्गोरिथम में क्या है, क्योंकि बिगो एसिम्प्टोटिक बाउंड जो मैक्सिमम होता है वही हो जाता है बिगो नोटेशन में, उसका लिमिट. तो एक्सपोनेंशियल ऑपरेशन यहाँ पे है कि मतलब बात यह है कि वो जो इटरेशन यूज कर रहा है अटैकर, जो लूप यूज कर रहे हैं, वो लूप कितनी बार इटरेट करेगा. इटरेट करेगा जितना नंबर ऑफ पॉसिबल कीज है. तो कितना नंबर ऑफ पॉसिबल कीज है, k बिट की है तो 2 पावर k पॉसिबल कीज हो सकता है. सो वी हैव टू ट्राई 2 पावर k पॉसिबल कीज, मतलब यू हैव टू इटरेट 2 पावर k टाइम्स. अब इटरेशन के अंदर में क्या कर रहे हो वो इंपॉर्टेंट नहीं है. इटरेशन के अंदर में कॉस्ट कितना है वो इंपॉर्टेंट नहीं है, बिकॉज दैट इज मल्टीप्लाइड बाय 2 पावर k. So that term, that execution time of a single iteration is acting as a constant, and that is coming out of that big O notation. Constant terms always get cancelled in big O notation. So it is becoming big O of 2 power k. क्या क्लियर हूं मैं? सब समझ पाए कि कोई डाउट है किसी का? नहीं होना चाहिए। तो exhaustive search is a not non-polynomial time problem. That is an example. It is not a non-polynomial time problem. तो आप ये नॉन डिटर्मिनिस्टिक पॉलिनोमियल टाइम बता रहे हो, इससे पहले आपको बताना चाहिए, एग्जांपल्स देना चाहिए। ये तो मैं क्रिप्टोग्राफी के फील्ड से दे दिया, लेकिन नॉन क्रिप्टोग्राफी कंप्यूटर साइंस के डिफरेंट दूसरे फील्ड से नॉन पॉलिनोमियल टाइम प्रॉब्लम क्या क्या है बताओ। एक्चुअली जहां पे भी एग्जॉस्टिव सर्च होता है, ऑल दोज प्रॉब्लम्स आर नॉन पॉलिनोमियल टाइम प्रॉब्लम्स। ओके, तो जैसे आपका एआई में जितने भी एल्गोरिदम यूज करते हो, आर्टिफिशियल इंटेलिजेंस में जितना भी आप लोग करते हो, जैसे आपका एनक्वीन प्रॉब्लम हो गया, मैप कलरिंग प्रॉब्लम हो गया, या फिर आपका ट्रैवलिंग सेल्स पर्सन प्रॉब्लम हो गया, या फिर और भी बोलो कुछ, ये जितने भी एआई में जितना भी प्रॉब्लम स्टडी करते हो, देखना उसका टाइम कॉम्प्लेक्सिटी सभी का एक्सपोनेंशियल टाइम है, किसी का भी पॉलिनोमियल टाइम कॉम्प्लेक्सिटी नहीं है। सो ऑल दोज आर नॉन पॉलिनोमियल टाइम एल्गोरिथम। डाउट्स है कहीं पे कोई? अच्छा, ये एक चीज बताओ, प्राइम फैक्टराइजेशन के बारे में बता रहे थे हम पिछले लास्ट क्लास में। प्राइम फैक्टराइजेशन, सपोज एक कंपोजिट नंबर आपको दिया गया है, कंपोजिट नंबर n, और ये भी बता दिया गया है कि उसका दो अच्छा, एक बस और सिंपल प्राइमलिटी टेस्टिंग, डिसीजन प्रॉब्लम, आपको एक नंबर दिया गया है, आपको टेस्ट करना है वेदर इट इज प्राइम और नॉट। क्या एल्गोरिथम आप यूज कर सकते हो? सर्च वर्च करने का कोई जरूरत नहीं है, आप सोच के बताओ बस।
तो सर टेस्ट चेंज कर रहा था उससे लेके
कि क्या हो सकता है, आप सोचो ऐसे।
टू से लेके रूट 2 तक,
हाँ, क्या करोगे?
सर 2 से लेके रूट नंबर तक, रूट उस नंबर तक का चेक करेंगे या
स्क्वायर रूट ऑफ दैट नंबर तक, क्योंकि हमको ये पता है, आप लोग मैथमेटिक्स में पढ़े होंगे कि कोई माने डिवीजर स्क्वायर रूट से ज्यादा नहीं हो सकता है, ये है ना लॉजिक?
यस सर, यस सर।
क्योंकि आप डिवीजर ढूंढ रहे हो है कि नहीं, अगर डिवीजर है उस नंबर का तो दैट इज नॉट ए प्राइम, अगर डिवीजर नहीं है तो दैट इज ए प्राइम। तो डिवीजर कभी एक नंबर n का डिवीजर कभी स्क्वायर रूट ऑफ n से बड़ा नहीं हो सकता है। So what you are saying that you will try all the integers one by one, starting from 1 or maybe starting from 2 up to square root of n. Is this what you are saying?
Yes sir.
हाँ.
Yes.
So कितना number of iterations हुआ?
root n minus 2.
मतलब बिगो नोटेशन में उसको लाओगे तो वही ऑर्डर ऑफ स्क्वायर रूट ऑफ एन ही हो रहा है, वो -2 हट जाएगा बिगो नोटेशन में, है ना? तो स्क्वायर रूट ऑफ एन मतलब n टू द पावर हाफ, n टू द पावर हाफ। अब फिर से मैं बोल रहा हूँ कि वो पुराना टर्मिनोलॉजी भूल जाओ इनपुट का, तो इनपुट साइज होगा नंबर ऑफ बिट्स पे। तो n मतलब n क्या है? n एक इंटीजर है, लेकिन इसका साइज कितना है?
सर k बिट्स मान लेंगे सर,
k बिट्स मान लीजिए। तो n इज इक्वल टू हाउ मच? n इज इक्वल टू 2 पावर k, माने मैक्सिमम।
यस सर।
बिगो नोटेशन पे क्या हुआ?
सर 2 द पावर k होल द पावर 1/2।
हाँ, that is equal to 2 order of 2 power k by 2.
Yes sir.
2 power k by 2. Is it polynomial time? Is it a polynomial time? Is it a polynomial function 2 power k by 2?
No sure.
No, because power में k है ना, पावर में k है, k by 2 हो चाहे k by 3 हो, जो भी हो पावर में k है। So this is not polynomial, this is again exponential time algorithm हो गया। So this is another example of आपका नॉन पॉलिनोमियल टाइम एल्गोरिथम। तो वहां पे भी जितना आप देखोगे कि जो है क्या क्या सब है ना, एन क्वीन प्रॉब्लम, और भी जितने सारे प्रॉब्लम है वहां पर देखोगे जितना टाइम कॉम्प्लेक्सिटी हो रहा है दैट विल कम इन ऑर्डर ऑफ एन। तो आप कंफ्यूज्ड मत होना ये सोच के कि ऑर्डर ऑफ एन है तो ये है लीनियर है पॉलिनोमियल टाइम नहीं। एन इंटीजर एक है वहां पे देखना एन इज एन इंटीजर। तो उस n को अगर नंबर ऑफ बिट्स पे कन्वर्ट करोगे तो दैट n विल बिकम 2 to the power k where k is the size of that input. So the complexity is becoming order of 2 power k. That means that is becoming an exponential time problem. Okay, ठीक है। अभी है हो गया पॉलिनोमियल टाइम क्या है। अच्छा एक एक चीज पहले आपको बताना चाहिए यहाँ पे। आप डायरेक्टली नॉन डिटर्मिनिस्टिक पॉलिनोमियल टाइम जा रहे हो इसलिए मैं आपको बार बार इंटरप्ट कर रहा हूँ। पहले हो गया पॉलिनोमियल टाइम क्या है, पॉलिनोमियल टाइम क्या नहीं है, कौन सा एल्गोरिथम नहीं है। अब ये पॉलिनोमियल टाइम नॉन पॉलिनोमियल टाइम इतना डिस्कस करने के बाद लोग तो पहले सोचेंगे कि क्यों इसको डिस्कस कर रहे हैं, पॉलिनोमियल टाइम में हमको इतना इंटरेस्ट क्यों है या फिर नॉन पॉलिनोमियल टाइम को किस में इंटरेस्ट है और क्यों है। ये बिना बताए अगर आप पहले नॉन डिटर्मिनिस्टिक पॉलिनोमियल टाइम में चले जाओगे तो इंटरेस्ट नहीं ग्रो करेगा। तो आप पहले इस पे थोड़ा बताओ कि पॉलिनोमियल टाइम और नॉन पॉलिनोमियल टाइम में कौन सा अच्छा है बुरा है क्यों है ये बताओ।
Usually we always try to achieve our algorithm in polynomial time so that the system will take much load, the CPU will not take much load, and this is the basic concept which we use in dynamic programming. What we do in dynamic programming is we try to simplify all the non-polynomial time equations into polynomial time by using extra space, like as you show the example of prime numbers.
अरे बहुत ऊपर में चले गए आप, इतना मत जाओ भाई, धीरे धीरे। पॉलिनोमियल पहले बताए, पॉलिनोमियल टाइम प्रॉब्लम, पॉलिनोमियल टाइम एल्गोरिथम आर मोर डिजायरेबल देन नॉन पॉलिनोमियल टाइम एल्गोरिथम। क्योंकि अपने बताए पॉलिनोमियल टाइम एल्गोरिथम लेस रिसोर्स कंज्यूमिंग है कंपेयर टू नॉन पॉलिनोमियल टाइम एल्गोरिथम। इसका मतलब थोड़ा और क्लैरिफिकेशन से समझो। अगर हो सके तो वो ग्राफ आप वहां से डाउनलोड करके देख सकते हो सर्च करके, फिर देख के मुझे, हम लोगों को, खाली मुझे नहीं, समझाओ कि ये क्या चीज बोले आपने। पॉलिनोमियल टाइम लेस रिसोर्स कंज्यूमिंग, नॉन पॉलिनोमियल टाइम ज्यादा रिसोर्स कंज्यूमिंग, क्यों? ये तो बस दो फंक्शन है, फंक्शन से क्या है मतलब, क्यों ज्यादा रिसोर्स कंज्यूमिंग है? उसका टाइम कॉम्प्लेक्सिटी, सपोज एक एल्गोरिथम मैंने लिख लिया, उसका टाइम कॉम्प्लेक्सिटी k⁻³ है, और दूसरा एक एल्गोरिथम मैंने लिख लिया जिसका टाइम कॉम्प्लेक्सिटी 2k है। तो ये ज्यादा रिसोर्स कंज्यूमिंग आपको समझ में कैसे आ गया? तो वो थोड़ा ग्राफ आप दिखा के समझाओ। कोई भी समझा सकते हो, खाली इस ग्रुप का नहीं, एनी एनी स्टूडेंट। मेरा क्वेश्चन आप समझ पाओगे ना? एक एल्गोरिथम किसी ने लिखा है जिसका टाइम कॉम्प्लेक्सिटी k² या फिर k³ जिसको आप पॉलिनोमियल कह रहे हो, और दूसरे ने कोई एल्गोरिथम लिखा जिसका टाइम कॉम्प्लेक्सिटी 2k है या फिर 3k है, 4k है, कोई भी, या फिर 2k/2 जो अभी अभी हमने बताया। तो वो बुरा क्यों है? वो ज्यादा रिसोर्स कंज्यूमिंग कैसे आप बता रहे हो, क्यों बता रहे हो?
Can you search the graph of x², difference of graph of x² and 2k/x with, or you can stop, I can share the screen.
Here is the graph of complexities.
So it is because we are computing the same value again and again.
Taking the example, when we talk about 2^10, it goes to nearly 1,000, but when we talk about 10^2, it goes to just 100. So exponential of 2^10 is much bigger than compared to polynomial of 10^2.
Can you stop sharing? I'll share my screen.
Okay.
So as you can see in this graph, there are two graphs. One is polynomial x square and another is non-polynomial, that is 2 to the power x. So the red one shows non-polynomial and the blue one shows polynomial. Now what happens is that as you can see on the positive side of the x-axis, there's a difference between both the graphs. At a single point of value of x, suppose 6, the blue one, that is our polynomial one, is showing a some value, while the non-polynomial showing giving the higher value than that on the y-axis. And as the graph progresses, the uh, rise in the value of non-polynomial graph is exponential. So you can just relate that y-axis as a cost of our computation while calculating. So that is why polynomial time are more preferred than non-polynomial, because in the long run they consume more computational times.
ठीक है, आप रखो 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 उसको रखो।
हेलो सर।
अरे उस ये को रखो जहाँ इंटरनेट पे दिखा रहे थे, शेयर करो। हाँ
yes,
अभी थोड़ा मैं और ऐड कर, कुछ बताना चाहते हो आप?
I am getting one point, sir. Like in the case of x square, we need to multiply like x into x. But in the case of to the power x, we have to suppose that you are increasing the value of x. Then you have to multiply it, number 2 as you increasing the value of x. So in the case of to the power x, the number of multiplication will increase as the value of x will increase. So that this may be the case. The complexity will increase in the case of exponential.
ठीक है, अब मैं कुछ ऐड कर लेता हूँ। देखो यहाँ पे ये जो ग्राफ आप देख रहे हो, यहाँ पे देखो जब x का वैल्यू 4 के आसपास, वहां पे माउस ले जाओ आप, हाँ 4 के आसपास है, उससे नीचे अगर x का वैल्यू होगा तो समथिंग इज डिफरेंट। बट जब x का वैल्यू 4 से ज्यादा होगा तो क्लियरली वी कैन ऑब्जर्व दैट दिस रेड कलर कर्व is growing much faster than the blue colored curve. ये बात आप हाईलाइट कर लो, मतलब अंडरलाइन कर लो मैं क्या बोल रहा हूं। ग्रोइंग not I am saying that the red color curve is higher than the blue color curve. That is true, definitely, but more importantly the growth rate, the rate in which the red color curve is growing is much higher than the yellow blue color curve. जब x का वैल्यू 4 से ज्यादा हो, मतलब if I make a generic statement, then it is something like that when, and this red color curve is actually the polynomial time curve and blue color is the non-polynomial time, linear polynomial time, sorry, red color is non-polynomial time, blue color is the polynomial time curve. So when the value of x, now what is x here? Actually x is the input size, and what is in the y-axis? Y is the time requirement, execution time of the algorithm, ठीक है? तो you are increasing the size of the input value of the x, definitely execution time is increasing, ठीक है? For both algorithms, for all algorithms, definitely it cannot reduce when you increase the size of the input. But the interesting point is that when x crosses a certain value, here that certain value is 4, but in general we say that x is sufficiently large. When the value of x is sufficiently large, sufficiently large का मतलब क्या है कि x का वैल्यू कोई एक certain threshold से ऊपर हो गया, जो अभी इस particular image पे 4 है, लेकिन वो कुछ भी हो सकता है, एक पॉजिटिव वैल्यू। उस वैल्यू से ज्यादा जब हो गया, x का वैल्यू जब sufficiently large होगा, तब you can observe always, not only for these two functions x square and 2 power x, any two functions you take of which one is polynomial and another is not polynomial, then you can always observe such type of thing. The thing क्या है कि जो रेड कलर कर्व होगा, जो नॉन पॉलिनोमियल टाइम कर्व होगा, उसका ग्रोथ रेट ब्लू कलर्ड कर्व से काफी ज्यादा होगा। फिर से आप ध्यान दो इस वर्ड में ग्रोथ रेट, मैं नहीं कह रहा हूं कि रेड कलर ब्लू कलर से ऊपर है, ब्लू कलर के ऊपर है, ऊंचा है और वो बहुत इंटरेस्टिंग है, वो तो ऊपर है ही, लेकिन इंटरेस्टिंग ये है कि उसका ग्रोथ रेट, अब ग्रोथ रेट का मतलब क्या है? ग्रोथ रेट का मतलब एक्स का वैल्यू कितना बढ़ाने से वाई का वैल्यू कितना बढ़ता है। इन अदर वर्ड्स डेल वाई बाई डेल एक्स, मतलब एक्स का वैल्यू 1 यूनिट अगर बढ़ा दो, 4 से अगर उसको 4.1 कर दो या फिर 4 से 5 कर दो, तो y का वैल्यू कितना बढ़ेगा। या फिर दूसरे वर्ड में कहूं 10% अगर x का वैल्यू बढ़ा दिए तो y का वैल्यू कितना परसेंटेज बढ़ेगा। डेल y बाई डेल x, जो डिफरेंशिएशन में बचपन में किए होंगे, dy dx, दैट इज द ग्रोथ रेट। dy dx डिफरेंशिएशन आप किए होंगे, याद होगा तो यू मे रिमेंबर that is nothing but at any point x, dy dx is nothing but the slope of the tangent drawn at that point। अब मन में सोचो, यहाँ पे मैं दिखा नहीं सकता, यहाँ पे वो जो ब्लू पॉइंट वहां पे रखा है माउस, वहां पे अगर एक टेंजेंट अब ड्रॉ कर लो, हिलाओ मत उसको, वहां पे अगर हम टेंजेंट एक ड्रॉ कर ले, तो वो जहां पे एक्स एक्सिस पे टच कर रहा है वहां पे जो एंगल क्रिएट हो रहा है, दैट इज एक्चुअली द स्लोप, दैट इज एक्चुअली द वैल्यू ऑफ dy एंड dx। तो आप जितना ऊपर जाओगी, देखो धीरे धीरे ऊपर उठाओ ब्लू पॉइंट को, देखो एंगल, ब्लू पॉइंट को धीरे धीरे उठाओ। हाँ, अब मन में सोचते जाओ कि वहां पे हम टेंजेंट ड्रॉ कर रहे हैं, तो देखो उसका एंगल धीरे 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 बढ़ेगा। अब अगर रेड पे जाओगे तो देखो सेम पॉइंट पे उसका टेंजेंट का स्लोप कितना ज्यादा होगा एज कंपेयर टू द ब्लू कर्व। उस पर जा नहीं रहा है शायद, तो अगर जाता तो देखते। अब मन में सोच लो, फॉर एक पर्टिकुलर वैल्यू ऑफ एक्स को कांस्टेंट रखो, मतलब एक वर्टिकल लाइन ड्रॉ कर लो, वो जहाँ पे ब्लू को टच कर रहा है वहां पे एक टेंजेंट ड्रॉ करो, और रेड को जहां टच कर रहा है वहां पे एक टेंजेंट ड्रॉ करो। तो देखो दोनों का, यहाँ पे देखो ये जो रखो, थोड़ा ऊपर रखो, थोड़ा ऊपर रखो, और हाँ बस बस, यहाँ पे अगर टेंजेंट ड्रॉ कर रहे हो तो ऑलमोस्ट 90 डिग्री हो रहा है, ऑलमोस्ट। जबकि आप अगर वो ब्लू पे रखोगे तो वो ऑलमोस्ट 60 डिग्री के आसपास हो रहा है। This angle is actually the slope that dy dx. So this is called the growth rate. So growth rate is much faster for a exponential curve than a polynomial curve. ये हो गया आपका इंटरप्रिटेशन ऑफ द ग्राफ। नाउ इससे हमारा बुरा नुकसान क्या हो रहा है, नुकसान क्या हो रहा है या फिर एडवांटेज क्या मिल रहा है। अब देखो मैं क्या बोल रहा हूं। अटैकर को एक प्रॉब्लम दिया गया है। नाउ अटैकर उस प्रॉब्लम को सॉल्व करने के लिए एक एल्गोरिथम लिखा है, उस एल्गोरिथम को वो रन करेगा। ठीक है, अटैकर रन करेगा। कौन कौन रन करेगा? अटैकर रन करेगा। अब उस अटैकर की एल्गोरिथम अगर पॉलिनोमियल टाइम ना हो, सपोज वो एक्सपोनेंशियल टाइम हो, मतलब उसका पॉलिनोमियल टाइम वो रेड कर्व वाला हो, तो क्या है, हम अगर देखते हैं कि अटैकर सॉल्व कर रहा है, कोई एक गिवन टाइम पे अटैकर सॉल्व कर रहा है उस प्रॉब्लम को, और हमको सिक्योरिटी थ्रेट है, तो हम क्या करेंगे, इनपुट साइज को बस 2-4 बिट बढ़ा दो, 1-2 बिट बढ़ा दो, तो क्या होगा, उसका एग्जीक्यूशन टाइम और बढ़ जाएगा, ब्लू कलर के लिए भी बढ़ेगा। लेकिन हमारा एडवांटेज यहाँ पे क्या है कि थोड़ा सा इनपुट बढ़ाने से उसका एग्जीक्यूशन कॉस्ट इतना बढ़ जाएगा कि वो अफोर्ड नहीं कर पाएगा। समझ गए आप लोग क्या मैं बोल रहा हूं? आप जब इनपुट साइज बढ़ा रहे हो, आपका एग्जीक्यूशन कॉस्ट भी बढ़ेगा, क्योंकि मैंने बोला आपको एनक्रिप्शन भी करना होगा, उसका कॉस्ट इज आल्सो डिपेंडेंट ऑन इनपुट साइज, बट दैट इज अ पॉलिनोमियल टाइम एल्गोरिथम, सो दैट विल आल्सो इंक्रीज, बट दैट विल इंक्रीज इन द रेट ऑफ द ब्लू कर्व। बट फॉर द अटैकर, मीनिंग आई एम एज्यूमिंग, हम एज्यूम कर रहे हैं कि आप जो एल्गोरिथम यूज करोगे, you are not the attacker, you are a legitimate party, so whatever algorithms you will use for encryption decryption are polynomial time algorithms, and suppose the attacker does not have a polynomial time algorithm, suppose he has only an this non polynomial time algorithm। अब बात यह है कि देखो, किसी को नॉन पोलिनोमियल टाइम एल्गोरिथम यूज करने से आप रोक नहीं सकते, क्योंकि मैंने बताया अगर उसके पास कुछ भी ऑप्शन नहीं है तो एटलीस्ट वो एग्जॉस्टिव सर्च तो कर सकता है। लेकिन अभी अभी मैंने एनालाइज करके बताया कि एग्जॉस्टिव सर्च ऑलवेज इज ए नॉन पॉलिनोमियल टाइम एक्सपोनेंशियल टाइम एल्गोरिथम, क्योंकि वो ऑर्डर ऑफ 2 पावर k हो जाता है। ठीक है, तो अगर उसके पास पॉलिनोमियल टाइम एल्गोरिथम मिल गया तो वो अलग बात है, लेकिन वी एज्यूम कि उसके पास पॉलिनोमियल टाइम एल्गोरिथम नहीं है, then in that case he can use always non polynomial time algorithm. और हम यूज कर रहे हैं इंक्रिप्शन डिक्रिप्शन, वी एज्यूम कि दीज आर पॉलिनोमियल टाइम एल्गोरिथम. तो अटैकर इज यूजिंग द रेड कर्व, वी आर यूजिंग द ब्लू कर्व. सो थोड़ा सा अगर हमको लग रहा है कि नहीं नहीं आज जमाना बदल गया है, अटैकर के पास बहुत हाई फाई कंप्यूटर आ गया है, तो थोड़ा सा इनपुट साइज बढ़ा दो, उसके लिए हमारा हमारा कॉस्ट भी बढ़ेगा, लेकिन वो पॉलिनोमियली ग्रो करेगा, मार्जिनली थोड़ा सा हाई होगा जो हम अफोर्ड कर सकते हैं. लेकिन अटैकर के लिए वो ग्रोथ इतना ज्यादा होगा कि वो जो अपग्रेड किया था मशीन उससे भी नहीं चलेगा उसको. मैं समझा पाया आप लोगों को?
यस सर.
तो ये है, यहाँ पे इंटरेस्ट है हमको कि पॉलिनोमियल टाइम एल्गोरिथम हम लोगों को चाहिए. एनक्रिप्शन डिक्रिप्शन डिजिटल सिग्नेचर जनरेशन वेरिफिकेशन मैक जनरेशन हैश जनरेशन, जितना भी क्रिप्टोग्राफिक एल्गोरिथम है, पॉलिनोमियल टाइम एल्गोरिथम ही चाहिए हमको, नॉन पॉलिनोमियल टाइम नहीं. लेकिन हम चाहते हैं कि जो प्रॉब्लम फॉर द अटैकर, जो अभी अभी हम मैथमेटिकली बताया, जो इनवर्स प्रॉब्लम है, इनवर्स फंक्शन है, हमारा फंक्शन अगर इंक्रिप्शन है तो इनवर्स जो होता है वो होना चाहिए नॉन पॉलिनोमियल टाइम. मतलब उसके पास कोई पॉलिनोमियल टाइम एल्गोरिथम नहीं होना चाहिए अटैकर के पास. अगर है तो हमारा सिस्टम सिक्योर नहीं है, उसके पास कोई भी पॉलिनोमियल टाइम एल्गोरिथम नहीं होना चाहिए. अब बात आता है एक कि ये दोनों के बीच में कुछ हो सकता है क्या? पॉलिनोमियल और नॉन पॉलिनोमियल के बीच में कुछ हो सकता है कि कुछ टाइप ऑफ एल्गोरिथम हो सकता है क्या? आंसर इज यस. वहां आता है आपका नॉन डिटर्मिनिस्टिक पॉलिनोमियल टाइम एल्गोरिथम. क्योंकि अभी तक जो हम डिस्कशन कर रहे थे ऑल आर डिटर्मिनिस्टिक एल्गोरिथम्स. इंक्रिप्शन डिक्रिप्शन डिजिटल सिग्नेचर जनरेशन जो भी हो, हम डिटर्मिनिस्टिक एल्गोरिथम की बात कर रहे थे. और अटैकर का प्रॉब्लम भी हम बात कर रहे थे, सोच रहे थे कि वो डिटर्मिनिस्टिक एल्गोरिथम यूज करेगा, लेकिन वी हैव नॉट कंसीडर्ड द सिनेरियो ऑफ नॉन डिटर्मिनिस्टिक एल्गोरिथम्स. नाउ आप नॉन डिटर्मिनिस्टिक पॉलिनोमियल टाइम एल्गोरिथम समझाने जा रहे थे, उससे पहले आपको बताना चाहिए, एक्सप्लेन करना चाहिए व्हाट इज अ नॉन डिटर्मिनिस्टिक एल्गोरिथम. पहले तो वो बताओ, फिर आप जाओगे नॉन डिटर्मिनिस्टिक पॉलिनोमियल टाइम. पहले आपको बताना चाहिए. आज तो टाइम खत्म हो गया, तो नेक्स्ट क्लास कल जो है आप थोड़ा और प्रिपरेशन लाके आ सकते हो, दूसरा कोई ग्रुप भी आ सकता है, इसमें ऐड करना. पहले यू हैव टू एक्सप्लेन व्हाट इज अ नॉन डिटर्मिनिस्टिक एल्गोरिथम. पॉलिनोमियल टाइम नहीं, खाली नॉन डिटर्मिनिस्टिक एल्गोरिथम क्या है बताओ. एक बात मैं बता भी दे रहा हूँ, नॉन डिटर्मिनिस्टिक एल्गोरिथम को रैंडमाइज्ड एल्गोरिथम भी कहते हैं कुछ लोग इसको प्रोबेबिलिस्टिक एल्गोरिथम भी कहते हैं. तो ये टर्म आप नोट डाउन कर सकते हो कॉपी बुक में, नॉन डिटर्मिनिस्टिक एल्गोरिथम, या फिर आप कह सकते हो उसको रैंडमाइज्ड एल्गोरिथम, प्रोबेबिलिस्टिक एल्गोरिथम. ये क्या चीज है और डिटर्मिनिस्टिक एल्गोरिथम के साथ इसका फर्क क्या है, और प्रोबेबिलिस्टिक एल्गोरिथम कितना डिफरेंट टाइप्स हो सकता है. जैसे मैं आपको बता रहा हूँ लास वेगास एल्गोरिथम, लास वेगास अमेरिका का एक सिटी है, लास वेगास एल्गोरिथम, और दूसरा एक कैटेगरी है मोंटे कार्लो एल्गोरिथम. ये दो टाइप्स ऑफ रैंडमाइज्ड एल्गोरिथम होता है, ठीक है. तो ये सब अब छोटा सा 2-4 स्लाइड ही बनेगा इसमें, डिटर्मिनिस्ट और एग्जाम्पल के साथ साथ इसको समझाना. डिटर्मिनिस्टिक एल्गोरिथम क्या है, जो एल्गोरिथम आज तक आप लोगों ने एल्गोरिथम कोर्स में पढ़े हो, सॉर्टिंग एल्गोरिथम सर्चिंग एल्गोरिथम ट्री के ऊपर जितना भी एल्गोरिथम पढ़े हो, ऑल ऑपरेटिंग सिस्टम कोर्स किए होंगे तो उसमें जितने भी एल्गोरिथम पढ़े होंगे, राउंड रॉबिन एल्गोरिथम, सीपीयू शेड्यूलिंग एल्गोरिथम, मेमोरी मैनेजमेंट एल्गोरिथम, डेटाबेस सिस्टम में जितने भी एल्गोरिथम पढ़े होंगे, ऑल आर ये आपका डिटर्मिनिस्टिक एल्गोरिथम. बट रैंडमाइज्ड एल्गोरिथम फिर क्या चीज है, वो किस किस काम में आता है? एक तो हम समझ पा रहे हैं कि क्रिप्टोग्राफी में उसको काम है, और किसी चीज में है क्या? मैं जैसे हिंट दे रहा हूँ, कंप्यूटर ग्राफिक्स में कोई यूज है क्या उसका? आर्टिफिशियल इंटेलिजेंस में कोई यूज है क्या उसका? ये सब चीज थोड़ा देख के आना, कल बता सकते हो. इंटरेस्टिंग चीजें हैं, ठीक है, आपको यूट्यूब में भी मिल जाएगा, लेकिन आपको थोड़ा स्लाइड बाय पॉइंट लिखना है. ठीक है, तो आज के क्लास के लिए कोई क्वेश्चन डाउट है अभी तक तो पूछ सकते हो.
Hello, sir.
है
Sir, please share the today's recording with us.
because I missed out on couple of points.
क्या बोल रहे हो मुझे समझ में नहीं आया anyway. ठीक
Sir,
है,
do
है
share the
कल
today's
पूछ लेना।
recording.
हाँ, अगर कोई सवाल है तो कल पूछ लेना, ठीक है? ठीक है मनोहर, you can end this meeting.
Yes, sir.
Thank you, sir.
Thank you all.